Hello, good morning, students. Hi, welcome to my class. Welcome to today's lesson. Okay, I hope you can hear me. Is there anyone in my class today? Oh, I see 10 comments here. Okay, so hello, girls. Hello, everyone. Hi, Stella, Corsin, Zishan, Crystal, Sini, Hui En, Jiao. Okay, Janice, Lin, Vivian. Okay, so many of you. Okay. Good morning. You can hear me? Okay, very good. Thank you, Stella. Thank you, Jishi. All right, so I will go straight to the lesson now. Okay, today we are going to go into 7.2, which is we're going to discuss the different types of energy. Okay, first of all, today we're going to just concentrate on potential energy. Okay, kinetic energy we will do other days. Okay, so I'm going to share screen now. Okay, I hope you can see this. Okay, is it all right? Okay, Puni, good morning. Patricia, Kaichi, Kosin, Jiatong, Eileen, everyone, good morning. Shereen. Okay, so today's lesson is important because you need to understand and you also need to know how to use the formula to calculate your energy. Okay, so I hope by the end of today's lesson, you will know how to use the formula to calculate two types of potential energy. Okay, so actually there are two types of potential energy. So let me look at, okay, right, sorry, I pressed something here. Let's look at the two types of potential energy. First of all, what is potential energy? All right, okay. Okay, Yanyi, good morning. Chloe, Winnie, good morning, everyone. Right, let's look at this. Now, we have learned energy. Energy is the ability to do work. And there are many types of energy. There is, of course, you have sound energy. There is, you've learned it in Form 1 before, the different forms of energy. Sound energy, light energy, heat energy, kinetic energy. So, potential is one of them. All right, you have nuclear energy. So many types. There are about eight types of energy. So today we're going to concentrate on potential energy. Okay, where's my pen? Oh, yes. So potential energy is one of the energies, and the unit for energy is always joule. Remember that. No matter what kind of energy you're talking about kinetic, you're talking about, let's say, heat energy or electrical energy, any form of energy, the unit is always joule. Okay, so now we're going to look at one of it. One of it is called potential energy. What is potential energy? Now, potential energy, it actually means the energy that is stored in an object. Potential means it is able to do a work. It can do it, but it's not doing it now. When an object has potential energy, it means that there is energy stored inside there, but it's not doing the work now. It can do. Potential means 有可能，它有那个技能 it can do. Okay, in Mandarin we call it is able to do work, but it's not doing it now. It's just stored inside there only, waiting for the chance to do the work. Okay, let's think of it that way. Very easy. It is energy stored inside an object, but it's not doing the work now. It will do the work when you give it a chance to do the work. Okay, now there are two types of potential energy. Okay, so potential energy, you can't see it. You can't see it doing the work, but the energy is there, waiting for a chance to do the work. It stored inside there first, store inside there. All right, at the moment, it's just stored inside there. So let's look at two types. Now, potential energy are two types. The first one is called gravitational potential energy. So for short, when I use G.P.E, okay, G.P.E, it stands for gravitational potential energy. Okay, when I say G.P.E. Now, what is the meaning of gravitational potential energy? This is a potential energy, a type of potential energy, but it's because of gravity. See the word here? Gravity. Gravitational means gravity. Now, you know that everything on Earth is subjected to gravity, isn't it? Everything will fall down because there's something pulling the thing to the ground or to the Earth. Let me draw you an Earth here. Okay, this is Earth. Right, this is the Earth, and we are all standing on the Earth here. Right, one of them. Okay, let's say you are on the Earth here. So you do not. Let's say you're holding something. You're holding something in your hand. Okay, you're holding something in your hand. So the thing doesn't drop. You're holding it in your hand. It doesn't drop because you are doing the work by stopping it from falling. So your hand is actually doing work. When you're holding something, your hand is doing work. So let me show you another picture. Here, look here. When you're holding an object, okay, the object is away from the ground. Let's say this is the ground. there is a certain height, right? If you do not hold it, definitely the object will drop. Everybody knows that. Primary students also knows it. If you do not hold it up, if you do not stop it, if you do not, we call it stopping. You're not holding the thing up, the thing will drop. Okay, actually your hand is doing a work. The work is stopping it from falling. Okay, so your hand is holding it, you're stopping it from falling. So there's a kind of work done. You are doing the work to stop the object from falling. Okay, so that's work done. At the same time, the object that you hold up will have gravitational potential energy. At the same time, it stores energy there. Why does it store energy? Because it can do work, but you're stopping it only. If you take your hand away, the gravity will make it fall. So it's actually the gravitational potential energy is inside now, waiting for a chance to fall, waiting for a chance to go down. But because your hand holding it, so the energy that is stored inside there in the box, in the that thing there, the object is still stored there. So your G.P.E is also there. And how to calculate the G.P.E? Okay, I'll give you a formula, right? So now let's look at G.P.E first. So the other one I will let you know later. The other type is elastic. All right, let me go to gravitational first before you get confused. So the first type of potential energy is called gravitational potential energy. It is because of the position of the object. Okay, the object has G.P.E or gravitational potential energy is because of the position. The position means it is away from the ground. The higher you put the object, actually the gravitational potential energy is higher. That means if the object is very far away from the ground, that means you put it very high. Okay, the higher you put the object, the higher the gravitational potential energy of the object. Okay, now it makes a lot of sense because you see, when object falls from a very high level, let's think of something very, very not so good. Let's say somebody wants to kill himself. Okay, now let's talk about it. Let's say if you jump, okay, if you jump from a very short level, okay, not very tall, not very high. You jump from, let's say, 1 meter from a chair to the ground, right? Your impact is not that great, isn't it? You're not going to hurt yourself. If you fall from 1 meter from the table onto the ground, right? Of course, you feel hurt, right? You feel painful, you feel there's a sound there. So the gravitational potential energy of you 1 meter away from the ground is actually very little. But imagine if you are in a tall building, okay, standing, let's say 10 meters away, or the building is 100 meters tall. You stand up there, and if accidentally, let's say you drop and you fall, what's going to happen? You find that the energy that you store inside there because of the height, when you drop, the energy is going to be very large. So when you fall and hit the floor and hit the ground, of course your skull will crack, everything will crack, your bones will break and all that because the energy is very, very high. So the further you are up there, the further the object is, that means you're the object, right? If you're falling, you're the object. So if you are very high there, you have a lot of gravitational potential energy. When you drop, the impact, the energy is very, very great. So when you drop down there, the impact, it converts into impact, right? When you drop into it, and you can see that a lot of bones will be broken and so on. So you have a major harm to your body. Okay, of course, the person may also die, right? That's why if you the distance is short, the gravitational potential energy is less. But if the distance is very, very tall, okay, rather, I mean, the height is very tall, right, very high, you find that when the thing drops, the gravitational potential energy actually is, when the thing is up there, it has a lot of gravitational potential energy. When it falls, it is going to create a lot of impact. Okay, so that makes a lot of sense, right? Now let's look at how to calculate your G.P.E. In order to calculate G.P.E, now look at this one, this object also, when you want to build a building, you need to drive the what you call a pile. This is to support the building. So you find that when you want to build a building, you find all these constructors, construction business, these companies, they will have to drive the pile into the ground, and they will pull it up, right? Pull it up, and then they will let it drop. So when it drops, the impact hits the pile, and it drops into the ground. Okay, the pile will go into the ground. So this is making use of gravitational potential energy. The hammer will have gravitational potential energy when you bring it up there. The higher it goes, the higher the gravitational energy. When it drops, the impact is higher. So it drives the thing down even deeper. Okay, so let's look at how to calculate. Now, gravitational potential energy, the formula is, look at this one. I will highlight this so you have to remember it's mgh. mgh. But you need to remember what is m, what is g, what is h. Okay, now let me discuss one by one. M stands for mass. This is standard. Whenever you see M as the not unit, this is the symbol. M is for mass, not symbol. Symbol M is for meter. This is called the physical quantity, the symbol of the physical quantity. M is mass, okay? And mass you calculate is in kilogram. Now this one not force, force is in Newton, okay? Force is in Newton, but mass is in kilogram. So remember, this is slightly different from what you've learned earlier. Force, work is equals force times distance. Force is in Newton. But here, when you want mass, always remember it's in kilogram. Okay, now G, what is G? G is called the gravitational acceleration. Now, you don't need to know in detail yet how to get this value. It is actually, what is the speed or the acceleration that something drops? When something drops from somewhere very high, it actually becomes faster and faster and faster. It's called acceleration. So it accelerates as it goes to the ground. Okay, and that value the scientists have calculated, it is actually around 10 meter per second per second. So the unit is ms-2. Okay, so the unit is, so you just have to remember this. Usually the G is already fixed, so no need for you to question it further. Whenever you see the G, you just take it as ms 10 meter per second per second. This is already been calculated and they've already measured. Actually, it's 9.8 lah. But to make it easy, it's actually 10. Okay, so this is how fast objects, we call it acceleration, the change in the speed. When the thing drops from the ground, actually it goes faster and faster and faster until it hits the ground. That value is calculated at 10 meter per second per second. So leave it like that. Okay, so this is G, and the H here is height. So you can see the difference here. You can see the relationship. The higher the object from the ground, you find that the gravitational, the mgh, the value that you calculate will be much higher. Depends on the height. And the height is in meters. Okay, standard unit for distance is meters. Okay, so now you remember this formula, mgh, mgh, if you want to measure gravitational potential energy. Okay, now let's look at the next one. What about work done? Okay, look at this example. Just now I talked about holding an object. All right, this cube up here. Now, actually, your hand, I said just now, is doing work. Your hand is doing work. Because what kind of work is your hand doing? Okay, holding an object. Actually, why you find it is it work? It is because if you don't hold this thing, the thing will drop. Actually, you're doing work. Now, what is the work done here? Work done here, as you calculated, you learned earlier, force times displacement. Correct? Okay, W equals to Fs. This is your last week's lesson. You want to calculate how much work by your hand, all right, is what is the force of the object you're holding, or actually the force times the distance. So, force, now how to get the force? The force is exerted, is the weight of gravity, is the pull of gravity on the object. So force is actually, you need to find the mass, you have to you convert into Newton. So how to convert this G is actually 10. I always remember, like I said, G is 10 meter per second per second. So that's why it's actually force is actually equals to weight or mass times the acceleration. So it's mg. Okay, so your force you can find from mg, the m times g, and displacement is the height. Okay, see the height here. So that's why mg. You can also find that the work done by your hand is actually equivalent to mgh. M is the mass of the object you're holding up. G is always 10. Height is the distance of the thing from the ground. So the work done by your hand is actually mgh also. Okay, so that means you can see the relationship just now. MGH is G.P.E, gravitational potential energy is MGH. Your work done is also MGH, so it actually means the same. Okay, your work done by your hand is to hold the object up. At the same time, your cube here is also having gravitational potential energy. It is also the same value. So the work that is done by your hand in holding up the thing is the same as the G.P.E of the object that you're holding. Okay, so you can see here the formula to calculate, you still use MGH. All right, okay, now let's look at one example of calculation. Okay, so do not look at your book first, just look at how to calculate. So let's say a typical question now. This shows a lift at KLCC Mall. I'm sure you've been there before, because before the pandemic, now you're not able to travel out of your state. The KLCC Mall, you see there's a lift here. There's a 5 levels, right? You can see there's a glass. When you go into the lift, it goes up, you can see outside. You can see every level as you go up. It's glass, some of the glass window, okay? Now, number one, the question says, the lift can carry a load of mass 1,500 kilograms. So you just underline or you just highlight all the data that are given. Then you can easily find it. So this is a mass, the human weight, the weight of the human or the load that is bringing up, 1,500 kilograms. Okay, all right. Next, how high is it lifting it? It's lifting up to a height of 30 meters. All right, so this is all you're given. Now, question one, let's do it together. Question one, how much work is done by the lift? So you need to find work done. The lift is doing work. What kind of work is it doing? It is bringing this whole thing up. It's bringing the thing up, okay? Because if it doesn't do the work, the thing is not going to move. So it is doing work. The lift is carrying this mass of 1,500 kilograms to a height of 30 meters. So it's bringing it up to 30 meters away. So work done, write your formula. Work done. And remember your formula for work done, which is force times displacement. Okay, force times displacement. This is your FS, right? The first thing you learned last week. Force, now how to find force? Force, you don't have Newton here. All you're given is your kilogram, isn't it? Given mass, this is mass, this is your mass, this is your mass, this is M, this is your height. So how to find force? Force is actually, you need to convert your mass. 1 kilogram is actually 10 Newton. 1 kilogram is 10 Newtons. Okay, so here is 1,500 kilograms. So when you times 10, it automatically becomes force already. It automatically becomes Newton. So you need to take whatever they give you as a mass in kilograms, you times 10. Now why 10? 10 is because of that one, like I said, it's fixed one. Okay, this is fixed. For G is always M times G, okay? The force is actually M times G. So your mass is 1,500. Your G is always 10. So what we do is we just put it here, 1,500, which is kilogram. You change to Newton, you got to times 10. This whole thing becomes force really. This whole thing becomes force. From kilogram, you change into force. Okay, then the displacement. Displacement is how far did the thing travel? Your lift bring the object, or then bring the mass of this load until what's the distance? So you can see here is 30 meters. All right. So now what you do is you just times everything. You take a calculator and just start punching. So 15 times 3 is 45. You just put back your zeros. 1, 2, 3, 4. So 1, 2, 3, 4. It means 450,000. What is the unit? What are we looking for? We are looking for work done. Work done is in joule. Okay. There you have found your answer. Or if you want, you prefer, you can change it to kilo. Whenever you see 3 zeros here, what you can do is you convert into a K. So it also same as 450 kilojoule. You can also put it like that. Okay, so I see some comments here. Yeah, force times displacement. Yes, the formula for work done, correct. So 1,500 times 10. Yes, because 1 kilogram is 10 newtons, so it becomes 150,000. Then don't forget to times your height, which is 30. You get 450,000. Okay, and the unit is joule. Okay, so you have already done first part, which is calculating the work done by the lift. Okay, now let's second one. What is the G.P.E? What is the gravitational potential energy of the lift? So when the lift goes up there at 30 meters height, what is the G.P.E of the lift now? How much energy is the lift holding now? Just like it's store energy. When the thing go up, it's storing energy. So how much is the G.P.E now at height of 30 meters? Okay, so let's look at G.P.E. Formula for G.P.E. Okay, formula for G.P.E, I just introduced the formula to you, which is mgh. So you can directly put mgh here. Just now the work done is force and displacement, but actually you find that it works out to the same number. Okay, so now let's see, this is what mgh. Okay, what is m? M is the mass of the object. So you're asking for the lift. Okay, they're asking this lift has got how much G.P.E when it's lifted at a height of 30. So you must know how heavy is the lift. Okay, the lift is given to you, the load of the mass of the lift, including the people inside there, is 1,500. Now this one no need to change because they want mass. Mass is in kilogram. Okay, just leave it as 1,500 kilograms. What about G? I mentioned G is how much? G is always, okay, 10 meter per second. Yes, mass times gravity times, yeah. Okay, so the gravity is called not gravity, it's called gravitational acceleration. Okay, just G, the G here stands for gravitational acceleration. It's always 10. Then you times your height. So your lift is now 30 meters high. So now you will add you times everything, you punch your calculator, you will also get the same value. Yes, which is 450,000 joules. All right, okay. So now you find the next question. Yeah, you've done your second part. Now the third one. What is the relationship then? What is the relationship between the work done by the lift and the gravitational potential energy? So these two, what is the relationship? You have already calculated work done here. See work done? You already calculated here. And then the second thing you calculated was the gravitational potential energy, you see? So you know this, the answer? This is 450,000. This is also 450,000, correct or not? So what is the relationship now? What is the relationship between these two? They're actually the same. The work done by your lift to lift the thing up is the same as the stored energy inside the lift now. Okay, once you bring the thing up, the energy will be stored inside there. So it's actually the same. Yeah, okay, Stella, you're right. So the work done, you find the answer the same. 450,000 is also the same as this one. So number C, okay, sorry, the C part here, what is the relationship? The relationship here is work done by the lift. Okay, the work done to carry the thing up, work done by the lift is equal to the gravitational potential energy of the lift. Once it go up there, it will have that same energy. Okay, that means this thing going up, the energy used to bring it up is now transferred to the lift once it goes up there. Okay, so this is your answer for C. No need to put figures, just say it's the same. This really, they ask for the relationship. Okay, now lastly, number D. What is the power? They ask you for power now. You still remember your formula for power? Can you type that? Okay, those who are here in the chat, can you write the formula for power? You remember your formula for power first. So number D, what I write here, D, write the formula for your power. Okay, power is what? Okay, can't remember? Go back and check your work now. Okay, so power, I can answer here, correct. You need to remember power is you have to find your work done first. Power is work done divided by the time taken to do the work. Okay, so that's why when they give you the this one calculation, they must give you the time. Otherwise, you cannot find the power. But don't forget your unit. Work done must be unit joule. The time must be unit of seconds. Okay, then only you're ready to put inside your formula. Look at the work done. Work done is you calculated how much? Okay, you calculate and let me know, girls. 450,000 joule divided by or time. Look at time. How much time are they giving you? They give you time is 0.5 minutes. Okay, so give me the answer, girls. What is your final answer here? Okay, I want to try. Oh, where you go? Okay, try to give me the final answer. Sorry, it keeps jumping around. Huh? Here. What is the final answer for your power? Okay, let me check. You have to, don't put 0.5 there because it is minutes. You change it to seconds first. So how to change the second? 1 minute, 60 seconds, correct? Okay, so let me do this way. So 1 minute, sorry. Okay, for those who are not too clear how to change, 1 minute is 60 seconds. Okay, so if you have 0.5 minute, you want to change to seconds, you have to divide by this number. Okay, divide by 60. So it becomes 0.5 divided by 60. Okay, 0.5 divided by 60. So what is the answer for 0.5 divided by 60? 0.5 is actually half. Okay, half divided by 60, that means it's times 60 is times over 60. You get 30. 1 minute is 30 seconds. 1 minute is 60 seconds. So half a minute is actually 30 seconds. All right, so what's your final answer? That's 30 seconds. Your answer, you got to cancel out, so you make it easier. You get 15000. Now, what is the unit now? What is the unit now? You're looking for what? You're looking for power. Power is watts. Yes, good. Watts. All right. You can leave it like that. Or if you don't want to see so many zero, you don't like so many zero, your 30, you can change into kilo. Okay, your 30 already equals to a kilo. So you just put a K, that's small K. Correct, yes, unit of power is watt. Okay, so you get 15,000 watt or 15 kW. Okay, so you see, it's not difficult. You need to know how to use the formula. What are the number they give you? You put inside and make sure the unit is correct. You get the answer. Okay, now let's go on to the next one. Elastic potential energy. Okay, elastic potential energy. So I need to go to this one. Second one. Go back to this one. What is elastic potential energy? Now this potential energy, the E.P.E, I call it for short, E.P.E, is an energy that is stored, both of them are stored energy. What do we mean by elastic? Okay, in 华语 we say 有弹性. 有弹性 that means it can go longer than original. You can stretch it, and also when you go, it should be able to back to the original. That is the meaning of elastic. If you can, you complete. When you let go, you should back to original length. That means the length can change depending force that you give it. You want it, let's say the original. Okay, let me draw you a spring. This is a spring. Or a spring is a very good of elastic. Okay, something that is. Let's look at the original length. The original length, let's say, is 10 cm. 10 cm. So you just imagine you take a ruler. If you have a spring, it'll be good. Look at the spring. 10 is the original length. So let's say using fingers, I press spring. When I press the spring, it becomes shorter, correct? Right? It's shorter, right? Okay, let me look at your comments. Anything here? Nothing so far. Okay, so if it becomes shorter, let's say 5 cm. It's 5 cm. So it is able to become shorter. But one thing, can it go back to our original or not? Cannot go back to original. You already press it and it stays like that. Then you don't say elastic. When it's elastic, it should go back to no length. Okay, so let's say I let go my fingers. So I press the spring, I let go. You notice that actually when you press it, it's inside that is storing the energy. It's actually ready to spring back. It wants to go back, but it cannot because your fingers are whole, correct? isn't it? When you press it, you're actually compressing. You're actually giving energy. It is stored. So now this compress. Okay, so it the potential because of the 它的情况，它的 condition. So whether it's compressed, when you press it, it will have the energy stored inside there. Okay, now is the same original is 10 cm. Now you pull it double the length. Now let's say this is 20 cm. Same spring, which is 10 cm only. Your two hands, you pull it away. So now your string becomes longer. Okay, now it's 20 cm. Now you can feel that the spring wants to go back. Isn't it? If you hard enough, it's a good spring. You find that you pull it long, pull it, you just want to pull, you can feel. So now it is 20 cm, it's long, you know. What happens? It's storing energy inside because it wants to go back. Waiting for let go. Once it let go, it will do work. The work is to come. Okay, so you can see there's energy inside the spring. When you let go, it's going to do the work is coming back. Okay? Now, let go, it will back to original cm. Then you call it elastic. Come back to the original. So this is called stretch. It's longer than usual, longer than the original length. The compress is shorter than the original length. Okay, so elastic must have these two properties. It must be able to become longer, but it can back, and able to become shorter, it will go back to original. That's why it's called elastic. So elastic energy is the energy stored inside the object, usually spring and all that, because of the object, whether it is compressed or whether it is stretched. Just like buying your toy, okay, your children's toy, inside there's a spring, isn't it? When you are turning the thing, you know that there's a key there, isn't it? You turn the toy, you turn it, cannot turn anymore. If it is spring in turning tighter and tighter and tighter, height that it stores a lot of energy. Once you put the toy on the floor, the spring going to go back to original. So it's going to open up. Spring open up in the wheel. So that's why your car can move. Okay, so this E.P.E. Now let's see how to calculate your E.P.E. stored inside the spring. Okay, it's clear. After we can go back to Google and then you just ask this. Okay. So now let's look at, you open up your stapler. All right, you will find very easily, you can see there's definitely a spring inside there. Spring, the first case here, you can come longer. So this is stretch. Spring is when it's stretched, it wants to go back to original length. And one load just inside there, and then you close it up, it is actually pushed. The spring is already compressed so it's already compressed. Compressed, it will press the stay forward long. So it's always at the front. Your staple is always pushed to the front. Then you can work it, you can use it. Let's see how to calculate E.P.E, the amount of E.P.E stored in your system. In, let's say, a spring that is compressed or stretched possesses elastic potential energy. So E.P.E for short. Okay, clear? Yes, go back to original, correct, compressed, right? Now, elastic potential energy is the work done because of stretch and elastic material, displacement X. So now your formula will be this. So you just need to remember this formula. Half F. Okay, so you need to explain what is F, what is half, you just leave it there. This is the constant. All right, you don't need to explain why you have an after. Of course, you want to explain, yes, you have the difference. Okay, then you can come up with this formula. I need for you to do this. I've done it for you. Okay, you're easy. Just need to use the formula. F is now the force. How much do you press the spring, or how much do you bring? The force that you give to the spring. F is the stretch or compression, and it is new because it's force. Okay, so remember this is different. Just now with G.P.E, you find, isn't it? So go back to force. So it's a little bit like, confusing. So when I use my kilogram, and with practice, you will remember how to do it. Okay, that's why you need to do a lot. So after classroom, all right, we will have to do questions. So half times F is the force. How much do you press your spring? Or how strong the spring are? That is your force. Next one, what is X? X is the displacement, means the distance. The distance from where? It's actually the change in the length. Okay, the change in the, and this one is in meter. So remember, unit is in Newton meter lah. Just remember, not Newton centimeter. It's always Newton. Okay, when you use a Newton, you will have meter together. Let's see how to do it. Okay, for example, here, look at, I have a spring that is originally 20 cm. Okay, I don't pull it, I don't stretch. This is original length, right? And then now what I did the spring here, let's say I push it, I make it shorter. Okay, I make it shorter, it becomes 10 cm shorter, right? You already push it and become shorter. So now, that's your F. That is your F. Okay, so the F that you put in your calculation, that is your F. How many Newton? In Newton, the force Newton. About X is the change in length. So change in length, original minus now. Or you can also put minus original. As long as there's change. Originally was 20. Now it becomes 10. So the X is change is 20 minus 10 cm. So your X is actually 10 cm. You don't put 20. Don't put your distance here is the displacement is correct. Yeah. But when you put in a formula, don't forget you have to put into meter. Your Newton must convert, your X must be converted into meter. Cannot just put in. Okay, I'm telling you how you change, see the distance. You must see the change in distance. Okay, let's look at the relationship between work and plastic potential energy. So look at the spring. The spring originally, if you tight here, the force is 0 because there's nothing pulling it down. At least you didn't do anything to pull down. Easy to put down, you heavy. You put something heavy, you put a block, put a ball, that will pull it down. The force. So now original length, let's say is 20 cm. Then now you find that after you put a certain force, you become longer because here, isn't it? It becomes longer. And the distance has already changed. Now the X is the change in distance, the difference in the original. So don't whole thing. This is wrong. Don't put the whole distance. Let's say now is 12 cm or 15 cm. Okay, don't put 15 cm. Because cm is the change. Original, sorry, 20. Sorry, 25 there. Okay, is original. That becomes another 5. So 20. Okay? So your is the X. Don't put 20. Put 5. Now let's look at let's say the question gives you in the form of a graph. You also can find or elastic potential energy if they give you the graph. Now, why is in the graph form? Because scientists have done this experiment when they put more and more higher, the weight is longer, the force is increasing. They find the stretching will also increase. The heavier object you put in there, the stretch, the become longer and longer and longer. So they draw a graph, and the graph is a straight line graph. Okay. So the long is the more the spring, the put there, the longer the spring will be. So you see how to calculate if I give you a graph. The formula is always, so is E.P.E equal to the area. You have to find this whole area, the area under the line, area under the graph. Okay, now go back to your mathematics. Think back about mathematics. I have a triangle here. How to find the triangle? Okay, now I want you to switch to your mathematics. Okay, you know what I mean? Now if you a triangle here, I need you to find the area of triangle. What is the measurement you need? This is right angle triangle. I need this, isn't it? And this, isn't it? Correct? The formula for triangle is half times base times what? Height, correct? Let me see. Anyone has got anything? Height is your area for the triangle. So the E.P.E is here, the area. I want to find the area is actually, if I find the elastic potential energy, actually I need to just find the area. The area under the graph, which is the shaded part here. Half times base times height. So what is half? Half is always base, the base. This base, if you see properly, it turns from here 0 to what? X. This is X actually. This is X. Base is X. What about your height here? Height is this height. This height is from here, you see F. This is the height. So this is F. Okay, half times height. So half times X times F. You will still get formula half Fx. You can see your E.P.E is always F. Okay, so now don't worry about understand this, is still fine. Whenever they give you a graph like this, they ask you to find your E.P.E, just find the area of the triangle under the graph there. And how to find it, you always think of your half times base height. And if they don't give you this kind, you just have to ask, they ask you for E.P.E, just remember half F times F. Okay, let's do one question, then you understand. All right, okay. So yeah, let's go. Yeah, okay, half times the height times the base, correct. So formula for your triangle. Okay, the original of a spring is 20 cm. This is original. So you underline or you highlight what given. When the final force exerted on spring is 20 newton, press it. Okay, I'm sorry, my phone is making a lot of noise. Let me just switch off this. Okay, so this 20 newton is pressing on the spring. You're pressing on the spring 20 newton. So it's shorter, isn't it? When you press, definitely the shorter. So 20 newton. New length, now the new length is 12 cm. Okay, so sometimes when they give you this question, you can realize it always helps to draw. You diagram beside. Some people prefer to have this kind of visual thing. You just read the words, I don't know what it's talking about, so just try to sketch. It helps. It really helps. For me, I always do that. Okay, now calculate what? Last thing, ask you for what? They ask you state potential energy. Find the E.P.E. Okay, E.P.E. Simple, right? So the first thing is always write your formula. Don't know how to do later. Okay, you don't know how to, never mind. Just write your formula. Once you look at the formula, you will know what to do. Half Fx. Okay, first of all, half you leave it there, always there. Okay, it's part of your F is equal. F is what is the force that is acting on the spring, pushing the spring or pulling the spring. Okay, so if your whole, if it's attached to some object there, then there is the mass times the 10, that is force. Given directly is 20 Newton. Just put your 20 there. Okay, times, next one, X. X is what? X distance, the change in the distance. Now here is 12. Oh, sorry, 20. Here is 12. Now, are you going to put 20 to 12? Which one are you going to put for your X? Okay, let me check your answer. I think someone has answered. Yes. Okay, I have got, yeah, 8 cm, correct. Do not take a lot of the mistake. And they see the second number 12, they just put 12 here, which is wrong. Two mistakes. Number one, 12. You need to minus 20x. 20 minus 12, you get 8 cm. But don't forget, this is in cm. This is in m. But you need to convert into what? You need to convert into meter. So it becomes 8 over 100 meter. Yeah, you cannot put 8 is also wrong. This is wrong. You have to put what? You have to put 8 over 100 or becomes 0.08 lah. Then it becomes meter. So your answer here is half times 20 is already 10 lah. Right? I'll just say this times 0.08. So your answer is 0.8. What is the unit? What are you looking for? You are looking for energy. Okay, what is the unit for energy? What is the unit? Whether it's G.P.E. or E.P.E. The answer is in somebody. Okay. Number 2, they forget to see the change in the length. Okay, make the mistake. All right, there are 2 things remember here. Number 1, change to meter for your E, and also look at the difference in the change, the change in the length. Okay, so I will start the kinetic energy will be another day because the calculation is a bit complicated. In fact, especially maths, also you need to have a calculator. You need to know how to do that. Okay, right. Okay, so I will stop the class here. Right. So we'll go to Google Meet just for give you your homework. We do some tests. Okay, so 777. I will see you. Don't run away. Okay. So for those, thank you very much for my video. So thanks, and I'll see you again on time. Okay, right. Bye-bye.